Good day everyone, I am Mas Diesto, and for today we're going to discuss about error detection and correction, specifically parity check. When the data is transmitted between the two digital devices, then due to external noise or interference, sometimes a few bits get corrupted in the data. And because of that, at the receiver side, the 1 is received as 0 and the 0 is received as 1. So for example, the transmitter is sending 1010, but if there is an error in one bit at the receiver, it might be received as 1000. So because of this error in one bit, the entire data get changed. There are two types of parity, that is odd parity and even parity. The number of ones in the code should be equal to odd for odd parity. For example, there are 7 data bits and 1 parity bit. So in this case of the odd parity, the parity bit should be such that the total number of ones in the code should be equal to odd. So as you can see, the total number of ones in these data bits equals 4. That means the parity bit should have 1 so that the number of ones in the code remains odd. Let's take another example. So in this case, the total number of ones in this data bits equals 5. Therefore, this parity bit should have 0 so that the total number of ones in the code remains odd. Similarly, in the case of even parity, the number of ones in the code should equal even. For example, this code has 5 ones in these data bits. That means this parity bit should have the bit 1 so the total number of ones in the code remains even. Let's take another example. So in this case, as you can see, the total number of ones in this data bit equals 4. This means this parity bit should have 0 so that the number of ones in the code remains even. On the other end, if we use the odd parity, then for the same data bits, this parity bit should equal 1 so that the number of ones in the code remains odd. So in this way, for error detection, the parity bit is appended along with the data bits, and the entire code will be sent from the transmitter to the receiver.